Right, so for second lesson video here, we're into prerequisites 3 and 4. So we're going to jump on into those. Again, this is all kind of stuff that you've learned before, just trying to remind you of all these things before we dive on into the book. So let me slide on down to this guy. And as always, these are notes that you can print from our class website. So hopefully you're doing that. You don't have to, but definitely makes the note-taking easier. So one of the things we're looking at today is just using linear equations like this one. So remember on these guys, best thing to do is look for a common denominator between all three fractions. In this case, it would be 6. So we're simply going to take that 6 and multiply it times both sides of the equation. Remember, you can do whatever you want as long as you do it to both sides of the equation. So I'm going to multiply everything by 6. Right here, my 6 divided by 3 would turn into a 2. So we're just multiplying that 2 times 5y plus 2 on the left. As I look right here, there's nothing for that 6 to reduce with. So I'm just multiplying 6 times 3. And for the last one, my 6 divided by 2 is a 3 times y. And we're given something like this, and now we have something much simpler to solve. So we're just going to go through real quick here and solve for y. So I'm going to distribute that 2. Subtract 3y from both sides. I'm going to subtract 4 from both sides at the same time here. So subtracting 3y is going to turn this into 7y. Subtracting that 4 is going to turn this into 14. And 7 divides in there nice and easy. And we get 2 for our value. So I just wanted to remind you of this process. I know you did this in Algebra 2, but there it is. So if you want to pause and, as always, and give this next one a shot before I do, you can. But I'm going to multiply everything by 15. So again, as I distribute to the, let me skip you through to the fast version here, but after we distribute, first line should look like this. And as you go through solving for x, this is where we finish. Of course, you can simplify this if we just reduce it to 5 over 2. All will be good. Moving on. All right, so, and again, something we've already talked about in our first video was the interval notation. Just want to make sure that we can write it that way. So sometimes as you're solving through an inequality, and you guys can see the solution, very simple, just getting x by itself. As you get x by itself and we get a solution that looks like this, remember how we learned in the last video to convert that to interval notation, because often you're going to be asked for this. So just want to make sure you're familiar with it anytime the directions ask you for it. So if we're going to say all the x is less than or equal to 1, because it's less than, we are heading towards negative infinity, and you'll always have a parenthesis on infinity signs. And because of the equal sign, that means we are including the 1, so that's why you get the hard bracket on the right side of that, on the right side of the 1. So just a quick reminder on that for writing answers in interval notation. You're commonly asked to write it this way. So one thing I wanted to remind you on cases like this, remember that when you're solving inequalities, anytime you multiply or divide by a negative number, it does flip your sign, so that's why you see the little sign change right here. So let me move on down to this one. Solving an inequality like this one, we're just isolating the x. Whatever we do, we simply do to both sides of the inequality. So first things first, we would want to multiply everything by 3 in order to get rid of our fraction here. So I'm going to multiply everything by 3. So it should look like this. Again, just trying to isolate the x, so we would add 1 to both sides. So I'm going to add 1 to everything. And then divide everything by 2. All right, so as far as graphing, so a couple things. This is all that we did in our first video. But remember, we can write this in interval notation. These are all the numbers from 2 inclusive. all the way up to 8, which is non-inclusive. So that is how it would look like in interval notation. And it's good to write it that way because when we graph on the number line, they want us to use those parentheses and brackets within our graph. So we would simply do something like this to show how it looks on a graph. So let me flip onto the second half here, P4. A little talk on slopes and some linear stuff here. So if we wanted to use point slope to write the equation of a line that passes through a point, so this is a point on the line, has a slope of -3. Remember, they call it point slope simply because you got a point and a slope. And so this is our point slope form that we look at. The x1 and the y1 refer to the point that you are passing through. So here's x1 and y1. And of course, the m represents the slope of -3. So we're just going to sub in the info. So y minus my y coordinate. They gave us a slope of -3. And then x minus the x coordinate. So instead of writing x minus -5, I'm going to write that as x plus 5. Save myself a step. So that's the answer in point slope form. If they ask for something in slope intercept form, right, all we'd have to do is get y by itself. So you would distribute the -3, you would add the 2 over, and then you got slope intercept form. But if they ask you for point slope, then we're going to go with that. So here's just a practice one if you want to give this one a try before we move on. So you can pause if you want. So that's what it would look like in point slope form. Going down to this one. So we are going to use graphing calculators quite a bit in this course. So this is the one I'm going to be using. Any TI-83, TI-84 would do just fine. I know they can be expensive. One option that you have is to try to find, you could try to find a used calculator through Craigslist or something like that. If you want to try to find a bit of a cheaper option. If you have an Android device, you can download the app called Wabbit Emu. That's WABITEMU. And you can actually put this on your Android device for free. Other option is to not use this type of calculator. You can always use an online program like Desmos or something like that if you don't want to use the graphing calculator, but this is what I'll be teaching from. So as we draw the graph, and I already know you guys know how to draw a graph for a line, so if this was my linear equation, I know that it starts my y-intercept at -3, and then from there I'm going to go up 3 over 2 to create this, but I just wanted to go through it with you on the graphing calculator. So if you go right here to y equals, this pulls up your graphing screen that looks like this. I'm simply going to type in the equation that I see right here. So I'm going to do 3 divided by 2. This is the button that we use for x. This is your variable button. So I'm going to hit that button right there. And then -3. And then in a second here, I'm going to hit graph to draw the graph. One thing we'll have to look at is something we may want to change depending on what we're doing is the window. Your typical window settings will look like this, right? So the x minimum is how far you see to the left. The x maximum is how far you see to the right. And your scale, I always count by ones for my scale. Y minimum, this is how low you'll see. And this is how high you'll see. So this gives you sort of the 4 dimensions of the screen that we'll be looking at for the graph. So I always go from -10 to +10 on both axes. That's like our standard setting. We can adjust that for other reasons as time goes on. So, but anyway, I'm going to go ahead and hit this graph button. And there's our graph. So we're going to get quite a bit of use out of these graphing calculators as the semester continues here. So let me jump to our last page. Yep, last page. So let me just show you these guys real quick. So again, equation of a line that passes through this point. And instead of telling us a slope for this one, all they told us is that it's parallel to this other line. So we know parallel lines have the same slope. So if I can figure out the slope of this line, that's going to be the slope of my line too. Right? So if I were to take this equation and get y by itself, it would look like this. You can see right here that my slope is -3/2. Since the lines are parallel, I know that's going to be my slope as well. So now I have my point and my slope, and now I can plug this into my point-slope form. So we're going to say y minus the y-coordinate equals our slope, x minus the x-coordinate. Now this one in particular does say slope-intercept form, so I want to make sure that I'm doing that. So I'm going to distribute my fraction on the right. So it would look like this, and then subtract 1, and we got our answer. Comes out looking like this. And then one last thing I'm going to show you to close this video out here. I didn't want to walk through the entire problem because it's almost identical to the one that we just did up above, with one exception. This one is now talking about perpendicular lines instead of parallel, so the only thing that would change in our process is to do the opposite reciprocal slope in order to get our slope. So for their line, as they get y by itself, you can see they had a slope of 3. So if I flip that and change the sign, I'm going to get -1/3 as our slope. Right? And so these would be perpendicular slopes. The rest of the process is just like the one we did up above in order to finish it off. So that's it for lesson 2.